Hello and welcome to this Staad.Pro V8i training session entitled Model Generation. This module covers the fundamentals of model generation in Staad.Pro. Various methods are demonstrated to create, edit, and view structured geometry, and topics will include the preprocessor's graphical environment, the structure wizard, working with the data tables, and the input file. The content of this module is specifically oriented toward models consisting of beams, braces, columns, and other linear entities. Staad.Pro can be launched a number of different ways. It could be launched from an icon on the desktop. It could be launched from the item within the Start menu, and it's also possible to put an icon on the Quick Launch bar. Any way that you find convenient. Once you launch Staad.Pro V8i, what you will be greeted with is a view that looks like what you see here on my screen, and it's what we refer to as the Start page. The Start page is broken up into 5 main sections. And I'm going to go through those now and explain those one at a time. So starting in the upper left-hand corner is a category called Project Tasks. The Project Tasks category has items that relate to project level types of things. So for instance, there's an icon that allows us to start a new project, an icon that allows us to open an existing project on this computer. There's also an icon that allows us to access an existing project from ProjectWise, which is Bentley's engineering project team collaboration system. There are also tools here in the Project Tasks category that allow us to configure the way the program behaves, to set up the parameters for a built-in backup manager, and then a tool to access the license management tool and to configure the server name and the activation key. Moving around the Start page clockwise, the next major category is called Recent Files. And what this does is it provides access to the last 6 models that have been opened on this computer with a single click of any of those model names. As you can see here, it also provides a thumbnail view of the models, and the data bubbles will provide information on the file path, and if the information was provided in the model, it will list the information like job number, job name, engineer name, date, and so on and so forth. The next section is called License Configuration, and this indicates which select licenses are being used by the current session of Staad based on the color scheme. The green colors indicate licenses that I have access to. Those circles that are grayed out are licenses that are not being requested. And if I was to try to request a license that I don't have access to, then I will get a red circle like you can see here, indicating that it's not accessible to me. Continuing around clockwise, this section at the bottom of the screen entitled Staad News is an RSS feed that is configurable. In fact, if I come up to the configuration item, I can show that there's a tab here specifically to configure that RSS feed so that I can pick certain categories of information that I'm interested in and rule out those that I'm not interested in, as well as an ability to select a geographic zone or region for which information will be provided. Last is the Help Topics category, and in the Help Topics we have a link for quick access to the online help document, a link that helps us to locate tech support centers and find contact information, and then some other links for finding the latest product news information, accessing a product knowledge base, and a link to specific information in the online help that documents the new features in this particular release. Before we leave the start page, there are two more important topics that I want to cover. The first of which is the fact that Staad.Pro has this built-in backup manager accessible from the project tasks category. And if I click the backup manager link, I can show that the first thing it does is it allows us to either turn on or turn off the autosave function. For the purposes of the training, I disable my autosave function simply because I'm never at a significant risk of data loss, because we'll be working from a series of saved dataset files. However, in production, it may be a feature that's worth considering, and then from there, if you decide that you do want to use the automatic backup function, you can configure how many backups you want it to save and at what frequency you want Staad.Pro to make those automatic saves. In addition, it allows you the option to configure how many manual save backups it retains. It allows you to indicate where you want the backups to be stored, and then provides some useful tools to compare and save as and open and view and so on, all of those backups that you may have saved on your machine. So for the purpose of our training, the significant item here is to make sure that that enable auto save option is deselected, so that you're not constantly hit with a warning to acknowledge that an auto save is about to be made. Since mine is already set that way, I'll just click the cancel button. I have no changes to make in this dialog. The other significant item that I want to talk about relates to the coordinate system and the base unit system that are used in Staad.Pro, both of which are accessible through this link here named Configuration within the Project Tasks category. So I'll click Configuration. The Configure Program dialog opens, and the first thing that I want to talk about is the Global Axis Orientation. So I'm going to click the Global Axis Orientation tab, and I can show that we have two options on this tab. One is to accept the default, which is that the y-axis will be oriented vertically, or there's a variant which allows us to establish the z-axis as pointing upward in the model. The thing that's of significance to understand here is that Staad.Pro is based on a global Cartesian coordinate system, an x, y, and z axis system. The default again is that the y-axis is vertical, which establishes that the x and z axes fall in the horizontal plane. The other thing that's of significance here is to note that while there is an option to reorient that basic coordinate system so that the z-axis is vertical, which might be useful in certain instances when data is being imported from some CAD program that's already assumed that the z-axis is vertical. Be aware that making that switch may have the effect of ruling out your options to use certain other functions in the program, one of which is the automatic wind load generator. So good practice is to try to use the program in its default orientation with the global y-axis oriented upward. The last item that I'd like to discuss while we're on the start page, still in the Configure Program dialog, relates to the concept of base units. So on the Base Unit tab, we can see that we have a choice of two different base unit systems, either English or metric. The base unit selection dictates the system of units that will be used internally to store the numerical values during calculations. And it also dictates the system of units that will be used to display results in tables and reports. So good practice is to set the base unit system so that it's consistent with the input units that will be used in the current working session. If your model is primarily based on English units, then English is the right choice for the base unit system, and likewise for metric units if a model is primarily based on metric units. Bear in mind that within any given Staad.Pro model, it is possible to change units on the fly and even to toggle from English units into metric units. The thing that's significant to understand is that due to the nature of the conversion between English and metric units, there is no exact conversion, and since only a finite number of significant digits can be carried in that conversion factor, changing between unit systems does introduce the potential for some error due to round off, so that does warrant some consideration. The default base unit system is something that can be chosen at the time that the program is installed and changed on a model by model basis, as we've seen here if necessary. So since I haven't made any changes here, I'm just going to click the cancel button at this point. With that basic introduction, we're now ready to begin our first exercise, which is to start a new project. In order to do that, I'll come to the Project Tasks category, and I'm going to click the link to New Project. That opens the New dialog box, and the first decision that we have to make about this new project is what type of structure do we want to create. The first option, the space type structure, is the one that we'll use, and it's the most universal type of structure that you can use in Staad.Pro. It will permit structures to be constructed in 3 dimensions. It's acceptable for any configuration of model geometry and loading, so it'll permit loading in all 3 directions. It'll permit deformations in all 3 directions, and it will be based on a coordinate system that follows the right-hand rule. The other 3 types of structures all take advantage of some sort of declared conditions to simplify the complexity of the stiffness matrix, to make the problem a little bit simpler to solve. Those different options are all explained in this text box here, and there's a good explanation for them as well in your training manual. So at this point, I'm just going to select the space type structure, and I'm going to move over to the file name field. I'm going to call this model that we're about to create my model, and then we have to decide where we want to store this new model. So what I'll do is click this button with 3 dots in it to show that it opens up a Browse dialog. In this Browse dialog, you can scroll to whatever location you want to use to store your data files. I've created a specific folder to store all of my models underneath the Staad folder, and that's where I'll allow this model to be created. So I can either click OK or cancel, since I don't want to make a change to that. The next thing that we need to do is decide what length units we want to start working in and what force units we want to start working in. My intent is to work with feet for length and kilopounds or kips for force units. So I'll leave those 2 unchanged, and then I'll click the next button. This brings us to a dialog named Where Do You Want to Go? And the purpose for this dialog is to select from a list of logical next steps that you might want to take as you work in your process of constructing this new model. So for instance, you might choose to go to the location in the program that sets you up to immediately add beams or add plates or solids. You might choose the option to go to the Structure Wizard, which is a built-in list of prototype structures that are quickly scalable and allow you to very quickly generate a lot of model geometry. You might choose the option to open the Staad editor, which is the location where we can edit the text input file that creates the backbone for the model. Or you might choose the option to edit job information, which is the one that we will choose. And this brings us to a location where we can populate those input fields with information like the project name and project number, the date, the engineer's name, and so on and so forth. The last step is to click the Finish button, and we will be on our way to working on a new model. Right now we're seeing a blank view of that model, and we could begin our modeling steps or begin to fill out job information if we wanted to do that over here in the data area on the right. So now that we've created our first working model here, let's just take a minute to work our way around the Staad.Pro screen and get familiar with the different elements of the graphical user interface. Let's start up here at the top of the screen where we have what we refer to as the menu bar. It's a list of different commands, each of which has a drop-down menu associated with it with individual commands available. Beneath the menu bar, in this area of icons, we refer to this as the toolbar. It actually consists of a series of individual toolbars that can be pulled out and dragged and dropped to different locations. They can be docked on the sides of the screen. They can be made to hover. Each toolbar has a name associated with it that you can see when you pull the toolbar off and float it or hover it. Each toolbar consists of a series of individual icons, which are tools that have a name and a function. If you decide that there's a toolbar that you don't need because you don't use those tools frequently, you can actually close a toolbar altogether, and you can see that in that way you can close things up on the screen here and reclaim a little bit of space. If you decide that you want that toolbar back, they can be recalled from the view item in the menu bar and then toolbars. Here's a full list of all the toolbars that are available. Here's the obvious one that we just turned off. I can just click that checkbox to recall the structure toolbar, and then if I wanted to, I could bring it back up and dock it again. The other thing that I'll point out about toolbars is that they can be customized in that you can create your own toolbars with this new button here. So if you wanted to, you could create a toolbar of all the tools that you use most frequently, and then just place that somewhere on the screen and close out the other toolbars that are less frequently used. Now I'll close this dialog and point out that the large area in the middle of the screen that's currently blank is what we refer to as the main window, and this is the location where you'll see your model take place graphically as you start to enter the model geometry information. Over here on the right hand side of the screen is what we refer to as the data area. The data area will contain different tables and spreadsheets and input forms depending on where in the program you are at the current time. This is the location where you'll interact with Staad.Pro digitally or numerically to enter data. Right now the data area is showing the job info dialog, and that's a function of the option we chose when we created this model, which was to say that we wanted to edit the job information in the where do you want to go dialog. Let's continue around clockwise here, and we'll take a look at the line at the bottom of the screen, which is referred to as the status bar. The status bar presents some helpful information regarding the general status of the model at any given time. So for instance, in the lower right hand corner we currently see that our working units or our input units are set to kip and feet. We can see by this piece of information that we're currently in what we refer to as the modeling mode. It's the portion of the program where we create or enter the information, the geometry of the model itself, as opposed to being in a post-processing mode where we can work with analysis data that we'll see later. And then over on the left side of the toolbar, you can frequently find tips and helpful information down here that'll indicate what Staad.Pro is expecting of you as a next step or as an interaction. So if you're ever in doubt as to what you need to do, take a look down here to see what Staad.Pro is asking for, and it'll commonly say click the next node or select this or do that. Continuing clockwise, this series of tabs on the left side of the screen is what we refer to collectively as the page control. And moving down through the page control, we will see a series of sub-tabs that are context sensitive to the selected tab. General workflow process is to work from top to bottom in the page control. If you do that, you'll be naturally guided through a logical process of creating a model, entering all of the necessary information, issuing appropriate analysis commands, and ultimately issuing design commands and parameters to get meaningful information out of the model. The next topic that I'd like to cover is the structural entities that are available for modeling in Staad.Pro. There are actually 5 different types of entities that we can use to model structures in Staad.Pro. The first of which is a beam, seen here highlighted on the screen. A beam is a linear structural member. Sometimes we'll use the term beam or member synonymously. The use of the term beam should not be taken to imply that a member can't resist axial load, because beam entities are in fact used to model both beams, bending members, as well as columns, braces, and other axially loaded members. The second item that we can work with, or entity that we can model with in Staad.Pro, is a node. And so I'll use the nodes cursor here to highlight a single node in this model. Very simply, nodes are just points of connectivity between other structural entities. We'll sometimes use the term joint and node synonymously, and nodes can be selected in Staad.Pro either by the nodes cursor or by this geometry cursor that's a catch-all. The next type of entity that we can work with in Staad.Pro is a plate. If I select the plates cursor, I can then click on this plate right here to highlight it and show that it's a single plate. It is a finite element that's commonly used to model surface type structures like walls, slabs, plates, shells, and so on. In Staad.Pro, we have the ability to create either 4-noded plates like you see here, or we can create 3-noded triangular plates. And plates again can be selected either by their own special plates cursor, or they can be selected by the geometry cursor. The next type of entity that is available in Staad.Pro is not one that we'll focus on in the rest of this training, but I'll just point out that we do have the ability to model solids. The entity that's highlighted here is just a single solid. These are finite elements that enable the solution of structural problems that involve 3-dimensional stresses. They're useful for solving things that involve stress distributions in relatively thick structures like concrete dams or soil and rock strata. In their basic form, solid elements consist of 8 nodes, but they do have the ability to be degenerated into various forms by collapsing one node onto another, so that they can take on different forms that have between 5 and 7 nodes. The last type of entity that we can work with in Staad.Pro is what's referred to as a surface. I can use a surface cursor and then click on this entity here to highlight a surface that's been added to this model. Surfaces are useful for rapidly modeling walls, slabs, and other planar type surfaces. They're similar to plate elements in terms of their structural behavior, but they're much faster and easier to model. An entire structure could conceivably be modeled very quickly with just a few surface type entities. And they behave inherently the same as a mesh of plate type elements. The program automatically subdivides surfaces into smaller finite elements based on the settings that are available for us to control. Now again, for this training we won't be using solids or surfaces, but I do just want to share one diagram here that I think is helpful in distinguishing when it's appropriate to use plate type elements versus when it may be required to use solid type elements. And this is in the training manual. But this illustrates 2 different structures, and it's emphasizing the differences in their least lateral dimension to thickness ratio. So when you take a look at any structure and you're debating the use of plate versus solid types of elements, what you'll do is evaluate the least lateral dimension of the structure and compare that to the thickness. If the least lateral dimension to thickness ratio is greater than 10, then that indicates that the structure is relatively thin and plate-like, and that it's generally acceptable to model that kind of a structure with plate elements. If the least lateral dimension to thickness ratio ends up being some value less than 10, then that's a relatively thick, stocky type of structure in which the through thickness effects tend to become significant, and it warrants consideration for using solid type elements for that kind of a structure. An important concept in creating model geometry in Staad.Pro is understanding how to work with grids. Grids are available to assist with model construction by providing dimensional control and creating snap points, and we can create and save multiple grid systems in a model. The limitation is that we can only display one grid system at a time. There are actually three different types of grid systems that we can create in Staad.Pro. The first of which is called a linear grid system, and I'm going to turn on an example of a linear grid system right now. A linear grid system is a two-dimensional system of regularly spaced linear construction lines that create snap points at their intersections. These lines don't necessarily have to be orthogonal, but they fall in a plane that can be defined as being coincident with the global XY, XZ, or YZ planes, or that plane can be rotated about one of those global axes. And the location of the origin of a grid system is defined with respect to the global X, Y, and Z coordinate system. Now another grid system that we can use is called a radial grid, and I'll turn on an example of a radial grid system right now. So a radial grid system is again a two-dimensional system of regularly spaced radial and circumferential construction lines that create a plane of snap points at their intersections. Again, this plane can be defined as being coincident with any of the three global planes, or it can be rotated about any one of the global axes. And again, the location of the grid system is defined with respect to the global X, Y, and Z coordinate system. Obviously, the radial grid system is one that's well suited for circular models using piecewise linear techniques to construct approximate curves and circles. The third type of grid system that we can work with in Staad.Pro is what's referred to as an irregular grid, and I'll turn on an example of an irregular grid right now. Irregular grid systems are, again, two-dimensional systems of regularly or irregularly spaced linear construction lines that create snap points at their intersections. So in this way, they're very much like the linear grid system that we saw previously, except that it removes the requirement of the lines being regularly spaced. Also, like the linear system, an irregular system can be coordinated with any one of the three global planes, or an irregular system can be rotated about any one of the global axes, like a linear system. But the irregular system also has an additional benefit in that it can be oriented by what's referred to as an arbitrary plane. That's specified by data that enters or defines two vectors that create an arbitrary plane. So in that way, it can be rotated about more than just one axis at a time. And then obviously within an irregular system, the benefit to them is that the spacing of the grid lines can vary in both directions and does not need to be regular within either direction. With that basic introduction to working with grids, we're now ready to move into our next exercise, which is setting up grids. So what we'll do is make sure that we're in the model that we've created previously called My Model. And then what I'm going to do is click on the Geometry tab in the page control. Notice that the Beam subtab is active by default. And by moving to that location in the page control, I now see a default grid that appears in the main window. I can also see that there is a floating dialog box named Snap Node Beam that was just outside of the shared view here. If I drag that in so that we can all see it, we can now see the controls that are offered on this Snap Node Beam dialog. And it's this Snap Node Beam dialog that we're going to use to create, modify, and edit grid systems in this particular model. So the first thing that I'm going to do is use the Create button. When I click Create, this little sidecar window pops out, and at the top of the sidecar window is a drop-down list box that offers the three different types of grids that we have available to us: linear, radial, and irregular. So I'm going to leave this set to linear for our example and come down to the name field where I'm going to type in the name training grid. And then what I'm going to do is click the OK button, which effectively accepts all of the default settings that are here. We'll come back to those in just a minute to see what the effect of those different parameters will be. But I'll click OK, and we see now a new grid system listed here in the Snap Node Beam dialog named Training Grid, with an indication that it's a linear type of grid system. If I click the checkbox in front of Training Grid, it now becomes the active grid. It doesn't look any different than the default grid because we accepted all of those default parameters, so it's effectively the same grid. Now what we'll do is we'll come in and we'll start to edit the training grid to make it unique from the default grid. So I'll come to the Edit button and click that. Again, the sidecar window pops out, and it offers me a chance to enter or modify all of those parameters except for the type of grid, which is locked down now as being a linear grid system, and I can't change the name at this point from this particular window. There's another way to do that here on a Rename button. We'll see that in just a minute. So for those things that I can control, starting here in the category named Plane, I can select what plane I want this particular grid to fall in, and what we'll do is leave it set to the XY plane. Then we have an angle of plane category, and what I could do in this area is, for instance, I could select the X axis and then indicate that I want a 45-degree rotation about that X axis. Then what I can do is come down to the grid origin fields here. When I click in the first origin field, notice that you can see the changes taking place in the background on the active view of this grid. So we can definitely see that something has changed as a result of this 45-degree rotation. Now, for illustration purposes, what we might want to do is change the origin of this grid system. So I'll come into the X field and enter a value of 10, and the same thing in the Y field. I'll move the origin of this grid to a grid location of 10, 10, 0. If I drop down into the construction lines category, I can see that I have two rows of data here, one pertaining to the X grids and one pertaining to the Y grids. So for demonstration purposes, what I might do is use these spinner arrows and indicate that I want 12 grid lines to the right of the origin for what we refer to as the X grids, and then I'll make it 12 grids to the right for what we call the Y grid lines. I'll leave the spacing values set to 1 foot for each of those different directions, and I'll also leave the skew angle set to 0 degrees so that we have an orthogonal system of grid lines here in our training grid. And with that, what I'll do is click OK. That makes it so that all those changes are saved and closes that little sidecar menu. Next, what I want to do is drop down to the bottom of the Snap Node Beam dialog and focus on this Active Grid Labels Setup category. What this does is it gives us some control over how labels will appear for the currently selected grid system, and what that implies is that the settings that we choose here in this dialog are applied to the currently active system, which means that I can establish different label setup configurations for different grids within my model. So to point out some of the things that we could potentially change here, starting with the category that's labeled ends. I have a drop-down list box that offers me some different options for labeling the ends of the grid lines. I can choose to label neither end, or I can choose to label both ends, or just the start or just the ending end of the grids. Moving to the right, I have a frequency spinner, which lets me label every single grid line or every second or every third grid. The X, Y, and Z buttons toggle the display of the X, Y, and Z coordinate labels at each location, so I can see just exactly the data that I want to see for each different direction. There are some checkboxes here named local coordinate, relative coordinates, and axis IDs, and by using different combinations of those options you can accomplish a variety of different alternatives for viewing the coordinates of grid lines. There's a table in the training manual that displays or illustrates some of the different options and the effects of those different combinations. But in short, the local coordinate checkbox toggles between displaying grid coordinates in a system that's local to the selected grid system as opposed to displaying coordinates for the global axis system. The relative coordinates checkbox toggles between displaying actual coordinates as opposed to the change in coordinate from one grid to the next. And then the axis IDs checkbox toggles on and off the display of the grid label X and Y so that it's easy to identify which ones are referred to as the X grids and which ones are referred to as the Y grids. There's also a font button here that offers a variety of different options for how those grid labels will appear, so we can change the font style, the size, the color, certain effects, and so on. The last thing that I want to describe here in the SnapNode Beam dialog is the function of the buttons in these two rows here. We've already seen the Create button. The Edit button would reopen the dialog to make changes to the selected grid system. The Delete button will delete the selected grid system. The Copy button allows you to make a copy of the selected system and then change its name and alter any of the parameters as necessary. The Rename button provides a way to change the name of the currently selected grid system. And then the Import button provides an option to import either a DXF file for use as a grid or to import a grid file from another Staad.Pro model for use in this particular model. So at this point what I'll do is return to our default grid, and I'll close the SnapNode Beam dialog, and then we'll be prepared to move into our next exercise. Our next exercise is titled Drawing Beams with the SnapNode Beam tool, and in the previous section I closed the SnapNode Beam dialog because I wanted to be able to show you a few different ways that you can recall that dialog box if it ever does get closed. The first way that I'll show is simply to come back to the Geometry tab, Beam sub-tab, and click on that tab again. That opens the SnapNode Beam dialog so that we could make changes or use the drawing mode. I'll close it again to show you some other ways to get that same dialog back. One way is to come to this icon, which is called the SnapNode Beam icon. It does exactly the same thing. And I'll show a third way to recall the SnapNode Beam dialog. I could come to Geometry, down to the Snap Grid Node item, and then choose the Beam option. And it does, again, the same thing. Recalls our SnapNode Beam dialog. Now what we're going to do is make sure that we're working with the default grid, and I can see that the checkbox is set there, so that's where we want to be. We'll use this default grid to draw a simple braced frame that's 8 feet tall and 7 feet wide. When I recall the Snap Node Beam dialog, we can see that the Snap Node Beam button is depressed, and I can also tell that we're in the drawing mode because the cursor tracks to specific grid intersections. This is the mode that tells us that we're ready to start to add beams to the grid. I can also see that there's a message down on the status bar that says add nodes or beams to line intersections using the cursor, and then it goes on to say that we can hold down the control key to reset, and we'll see the purpose for that in just a minute. Now, in its default mode of operation, the Snap Node Beam tool will only snap to grid intersections, but it's important to note that there's an option here with a checkbox called Snap to Existing Nodes Too, and when that is activated, the Snap Node Beam tool will be able to snap to any node in the model, which can at times be useful. For instance, if there's a need to snap to a node that's out of the plane of the current grid, or if there's a need to snap to a node that's outboard of the current grid, even if it's in the same plane. And a third reason that we might want to use that checkbox is if we needed to snap to a location that was within the current grid system but didn't occur at an actual grid intersection point. We'll come back and discuss that option a little bit more later, but for now what we'll do is just use the basic default form, which will snap only to grid intersections, and we said that we want to draw an 8 foot high by 7 foot wide braced frame. So what I'll do is move my cursor down so that it snaps to the origin of the grid, 0, 0, and I'm going to click once and then just stretch up and away, and I notice that I now am rubber banding from that initial point. That point that I clicked first is actually red, and that's what is referred to as the hot spot in STAAD lingo. That's the spot from which the next beam will originate unless I do something different. Well, that's the place where I want it to start, and I want it to come up 8 units. So I'm just going to move my cursor up to a grid location of 0, 8, and I'll click again. And now when I move away, you can see that I'm rubber banding from that grid location 0, 8. The red dot has moved up there, meaning that my hotspot is now here at the top of that vertical member, and the next member that I draw will originate from that spot and go to my next click location. Here we said that we wanted to draw the braced frame 7 units wide, so I'm going to come over 7 units and click once more, and then again I can see that I'm rubber banding from that location, so I can stretch all the way back down to the grid location 7, 0, and click once more. And now if I wanted to, I could actually stretch up to the opposite corner, the grid location 0, 8, and click again to draw that first diagonal. At this point I find myself in a little bit of a fix because my next member doesn't want to originate from this particular location, and this is where we'll take advantage of this statement that we see down here on the status bar that says hold the control key down to reset. So what I can do now is press and hold the control key on my keyboard and move my mouse cursor around and see that I'm no longer rubber banding from the hotspot, which is still up here at 0, 8. If I wanted to reset that hotspot, say down to the origin, I could just hold the cursor, hold the control key down and click my cursor at 0, 0 and move away, and notice that the red dot is now down at the origin. Now I'll release my control key on the keyboard and move my mouse around and see that I'm now rubber banding from that origin location to any of the new grid intersections. I can come to the upper right corner of the frame and click once more and see that I've just added the second diagonal member, and then at this point I want to stop drawing. The way that I tell Staad.Pro that I'm done drawing is I come over to my Snap Node Beam dialog and toggle off the Snap Node Beam button. Now we can see a change in the appearance of that button, and I can see when I move my cursor back across the grid that I no longer have that crosshair type grid, and it's no longer tracking to grid intersections. So now I'm done drawing members on the grid. It's now a convenient time for me to make a few comments about grid setup and the behavior of grid systems in Staad.Pro. So the first thing that I'd like to say is to use grids to their best advantage. Recognize the fact that we drew a 7 unit by 8 unit frame on a 10 by 10 grid, and understand that in the process of doing that we had to eyeball the coordinate and make sure that we were at 7 units over and 8 units up, and recognize the fact that we could have just as easily edited this grid system so that it was exactly 8 units high by 7 units wide, and we could have just quickly snapped to the extreme corners of the grid system. Also recognize that there would be nothing that prevents us from setting up a 1 unit by 1 unit grid system that had a spacing of 8 feet in the vertical direction and 7 feet in the horizontal direction, so it was literally just one big square with only 4 intersections to potentially snap to. So the key there is to make sure that you use grid systems to their best advantage. Related to that topic is the way that grids in Staad.Pro behave. The entities that are placed using this default grid are not actually attached to that grid. To demonstrate that, what I'll do is choose to edit the default grid and arbitrarily decide to change the spacing of the X grids from 1 foot to 1.5 feet, maintaining 10 of those grids in that direction. And when I click OK, what we can see as expected is that the 10 units or 10 lines now stretch out to 15 units, but we can see that the original geometry, 7 feet long, for this uppermost beam doesn't change. So the way that grids behave in Staad.Pro is that they can be thought of as a piece of grid paper underneath a vellum, and it makes it possible to change these grids on the fly as is convenient while you're working on your model. Just to reinforce that, I can again edit the default grid system, change the spacing back to 1 foot, click OK, and now I'm back to the original grid system that I used to draw this frame. This is a good time for me to point out that Staad.Pro has both undo and redo tools, and to demonstrate how they function. First of all, if I click the undo tool once, I can undo the most recent step. If I click it again, I can undo the step prior to that, and so on. The redo tool works in the opposite direction, so I can redo once to add 1 diagonal back, redo again to add the second diagonal back. In addition to being able to function in this one at a time mode, the undo and redo tools also have a cache of the last so many modeling steps that have been performed. So if I knew I wanted to undo all the way back to the 4th step, I could click back down to the 4th item here and actually double click to undo all the way back to that point. I could also choose to redo all the way back so that my model is restored to the way it was originally. Now, some important points to understand about the undo and redo functions. First of all, Staad.Pro will purge that undo cache in the graphical user interface if any changes are made in the command file editor and the save command is issued. So nothing that was done in the graphical user interface before the command file was changed and saved will be available to undo. Also, when working in the command file editor, there is an undo function there as well, but once changes are saved and the editor is closed, that cache is also purged. Finally, it's important to understand that they are separate caches, so the undo command in the graphical user interface cannot be used to undo changes that have been made in the command file editor. At this point, what I'll do is close this model without saving it, and this will set us up to perform our next step, which will be to look at the Add Beams tool. The next tool that I'd like to discuss is called the Add Beams tool. It can be found here with this icon that's located on the geometry toolbar. Its purpose is to add beams from a point to point, but it differs a little bit from the Snap Grid Node tool that we saw previously in a couple ways. First, the Add Beams tool only adds one beam at a time. It does not automatically assume that the end of one beam becomes the start of the next beam. So, in order to demonstrate this tool, I've opened the saved dataset file named modeling1, and then I'm going to come up and activate the Add Beams tool, and I'm going to assume that my intent is to just recreate the cross braces in this particular bay. So I'm going to start down at the lower left hand corner, and with my cursor reasonably close to the node at the lower left, I'll click once and stretch up and away, and notice that I'm rubber banding from that point. So this beam that I'm drawing just snapped to that node, and I'll come up to the opposite corner and again get reasonably close to the node and click once and move away, and I can see that I've left a single beam. If I wanted to draw the second beam, I could click at the upper left hand corner and stretch down and click near the lower right hand corner, and now I've recreated those two diagonals. Now the other way that the Add Beams tool is a little different from the Snap Grid Node tool is that it also allows beams to be drawn from places where no node currently exists. To demonstrate that, let's assume that we want to create a knee brace from the midspan of the horizontal member down to the mid-height of the column on the right. What I'll do is put my cursor near the midspan of the beam and just click once. When I do that, Staad.Pro senses that I've just made a click with this tool nowhere near any existing nodes, and so it offers me the option to insert a node at that location. Let's say yes, that's my intent. When I do that, I get the Insert Nodes into Beam such and such dialog box that shows me the length of the beam that I just clicked on, shows me a graphic representation of that beam, indicates that that member spans from node number 2 to node number 3, and in the new insertion point category it shows me the distance from the starting end of the beam to the point where it interpreted my click, very close to the center. It shows me the same information in a proportion form, so about 52% of the length of the beam. And then it gives me some options to add actual insertion points into this member. So we said that we wanted to add a node at the mid-span of this beam. I could come in and just do some mental math and enter 3.5 here. I could also do a 0.5 proportion. Let's do 0.5. Notice that it dynamically updates the distance to represent 1/2 of the 7-foot length. When I like that insertion point, what I can do is click this button, Add New Point. And what that does is inserts that point in this list of insertion points and automatically puts a tick mark along the graphic representation of the beam and shows me that the new node that will be entered will take on number 5. Let's say that I only want to enter that one node here in order to draw that knee brace. At this point, what I can do is click the OK button, and we'll see that I've left a node at the midspan of this member. So bear in mind now that what once was a continuous member from column to column has now been broken into two halves separated by this new node. And then the other thing we see is that we're rubber banding from that new node, and our status bar in the lower left hand corner is telling us that we can release on the node at the other end of the beam. Well, it so happens that there is no node at the other end of our knee brace because we said we wanted it to go to the mid-height of the column. So again, what we can do is just click anywhere along the length of that column as long as we're outside of the little snap area near the two end nodes. And again, it comes up with the dialog that offers for us to insert a new node at that location. Yes, that's what we want to do. Here's the insert nodes into beam such and such dialog box, a graphic representation of the column spanning from node 3 to node 4 with an overall length of 8 feet. Again, we could do the mental math. We could key in 50%, but it's such a common point to want to insert that they've even given us a button that specifically adds a midpoint in this list of insertion points. So there is 4, which is half of 8, and that's all we want to do, so I'll click OK. And there is our new node that has now split the one-piece column into 2 equal length pieces, and all I need to do is just click right near that node, and I've added that new member here as a knee brace or a diagonal. Now, this is a good time for us to discuss what we refer to as flyout toolbars in Staad.Pro. Flyout toolbars are signified by some icons up here that have small black triangles in the lower right hand corner. The way they function is if we put the cursor on any one of those icons and click and hold the mouse button, the flyout toolbar opens up with a series of related tools that perform similar functions. So to demonstrate in this case, what I'm going to do is choose the third one in from the left, which I know to be the Add Beam Between Midpoints tool. That tool now becomes the active tool on that button. Notice that it doesn't automatically become activated though. In order to activate that tool, I need to come back up and click it. Now it takes on that depressed appearance. We're now in the mode of adding beams between midpoints, and we'll see that this is an even faster way of doing what we just did over here. Let's assume that we want to add another knee brace that will run from the midpoint of the left half of the horizontal beam down to the mid height of the column on the left. The status bar tells me that I can just select the first beam. So I'm going to click somewhere along the length of the left hand beam and then move away slowly so that we can see that it definitely did snap to the midpoint, just as the tool implies. And then again, I'll do the same thing over here on the column on the left. I'm going to click somewhere along the column, not near the end nodes and not near the mid height, and notice that it noticeably jumps down there to the mid height of that column. Finally, good practice is to just come back up and toggle that tool back off so that you don't make any unintended changes by clicks on the screen after you're done using it. Now that we've looked at a few different ways to construct model geometry graphically, what I'd like to do is demonstrate how we can create geometry using the tables in Staad.Pro. So in order to demonstrate this, I've opened up Modeling 2 from the data set, and I'm going to move to the Geometry tab, where I'll automatically be on the Beam sub-tab. And what we'll do now is we'll move our focus over to the data area where we'll see 2 tables. The uppermost table is referred to as the nodes table. It lists the x, y, and z coordinates for the nodes that are entered in the current model. We can see that there is one node currently entered in this data set model, and it's located at the origin. The table on the bottom is referred to as the beams table, and we'll use this to enter the what we refer to as the member incidences that describe the nodes that form the ends of each successive beam. So working from the data that's presented in the training manual, what I'm going to do is come back up to the nodes table and use it very much like a spreadsheet. So I'll click in this cell in row 2, x coordinate, and I'm going to enter the values of 0 and then use the right arrow on my keyboard and then enter 8 and use the down arrow and left so that I've left a 0, 8, 0 coordinate for node number 2. When I did that, that second node appeared here in the main window. The other coordinates are 7, 8, 0, Here's the third node appearing. And then finally we need to enter a 700, so there's 7 and it's automatically 00. So now we can see that we have the 4 nodes that will form the corners of the same braced frame that we created in the previous exercise using graphical methods. The next step will be to move down to the beams table. I'll click in the first cell, and what we're going to do here is indicate that beam number 1 is going to span from node number 1. Use the right arrow to move to the other cell and say that it spans to node number 2. And when I move off of that cell, we'll see a graphic representation of that first beam going from node 1 to node 2. I'm going to say that the second beam will span from node 2 to node 3. Again, I'm using the arrow keys on my keyboard to move between these cells, just like a spreadsheet. I'll say that beam number 3 is to span from node 3 to node 4. And then I'll create the cross braces by saying that beam number 4 will span from node 1 to node 3. And finally, we'll say that beam number 5 will span from node 2 to node 4. Once I move off of that cell, we can see now that we've recreated the same braced frame geometry that we had in the previous exercise without ever clicking anywhere in the main window. We did this entire model construction digitally by entering the data here in the data area over on the right side of the screen. Continuing on with the subject of creating structure geometry, the next topic that we'll cover is using the structure wizard. And in concept, what we'll do is discuss how we could use the structure wizard to create geometry that would represent the mill building frame that you see here in the training manual. And in concept, what we'll do is use the structure wizard to quickly create 1/2 of this truss. Then we'll see steps that will show us how to add a column to the eave of the truss. And then later in another exercise, we'll see how to use the mirror command to mirror that and end up in the overall construction of the mill building bent that we see here. So in your Staad.Pro application, if you still have a model open, you can close it to return to the start page, and then what we'll do is we will use the new project icon here in the project tasks category. We'll say that we want to create a space type structure. I'm going to choose to name this model structure wizard. And again, I'll just take a quick look to make sure that I know where it intends to put the model. It's in the location that I've been storing everything else, so I'll leave that unchanged. And then I'll select foot for my length units and kips for my force units and click the next button. Then in the where do you want to go dialog, what I'll do is come to the option to open the structure wizard, and then I can click finish and resize this to the shared region. Now the structure wizard will open as a second window on top of your Staad.Pro application. I'm resizing it now so that we can see the full structure wizard window. And the first thing that I want to do is point out that there's an option to use either built-in prototype models that come with the program, or there's an option to recall saved user models, because part of the functionality of the structure wizard is to allow you to create and save your own commonly used prototypes. If you have a lot of repetition in the work that you do, you can set up a prototype that will allow you to quickly define your structure parametrically and generate model geometry, much like the prototypes that we're going to take a look at in just a second here. So we'll stay on prototype models. The next thing that I want to do is use the File menu item in the Structure Wizard window to show that there's a Select Units item, and I want to take a look to make sure that my units are in feet. The thing that's important to understand here is that the Structure Wizard does not require you to use the same system of units that the current model is using, which can be helpful if you're generating geometry for a component that you want to insert into a model, and perhaps the information for the component is provided to you in inches where the units for the model itself are in feet. In this case, though, what I want to do is make sure that my units in the Structure Wizard are in feet, which they are, so I can click OK or cancel. The next thing that I'll do is use this model type list to show that there are a variety of different types of built-in models that are available for us to use. What we'll do is we will choose the truss models, and then from there we'll choose this, the North Light truss as the one that we want to start with. We can either double click the North Light truss icon, or we can click and drag and drop over here on the right hand side. Either way results in the same thing. It opens the Select Parameters dialog, shows us that we've chosen the North Light truss, and then gives us the parameters that we can control to establish the geometry for our particular North Light truss. Now, based on the original problem statement, we want to create an overall span of 50 feet. So for this half of the structure, we want to enter a length of 25 feet. The height from the eave to the ridge happened to be 10 feet, so we can leave the 10 as a default value. What's of significance with the width direction is that we're going to indicate that we want to create 0 bays along the width. That's the way that we can tell STAAD that we want to create just a single planar element rather than creating multiple elements separated by some value. So for that matter, the width value that we enter here is irrelevant once we tell it that we want to create 0 bays along the width. And then finally, what I'll do is make sure that we have the number of bays along the length set to 4 to match the geometry that we saw in the training manual and the problem statement. And I'll show that the function of this 3 dots button is to allow us to change the distribution of the lengths of those bays. So the default, as we're seeing here, is to assume that each bay is equal length. In other words, it takes this length and divides it by this number of bays. We can change that proportion if we want to. The requirement is that the sum of the lengths that we enter must equal this length value that we keyed in back here. For our purposes, we'll just accept the default of equal length bays, so I can click OK or cancel. And then what I'll do is click the Apply button. Now I'm shown a view of the North Light truss. I can use my mouse cursor to just click and drag and spin it around and take a look at it from all different directions. There are also some other ways to navigate and take a look at the proposed prototype. There's some buttons up here on the top that go to orthographic projection views and back to the isometric view. There are some spin and rotate tools that allow you to move incrementally about each of the 3 global axes. There's some zoom in, zoom out, and pan. And then there are even some functions that can be helpful in more complex prototypes, where you press and hold the Shift key and click and open up some orbit paths. And then if you click near a specific orbit path, you can, in a controlled way, rotate the structure about just one axis at a time. If you release the Shift key and press the Control key instead, you can rotate about these 3 axes in a controlled way by clicking near either the crosshairs or the outer circle. I'll release the Control key, click once more to just reset that view, and click the isometric view button to bring it back to its original form. Now let's just assume that we took a look at this view of the structure and we picked up that we had made an obvious error and we wanted to get back to those parameters. We could just double click on this right hand side and recall that select parameters dialog, make any change that we wanted and click apply, and quickly see the effect of that. I just changed the length from 25 feet to 250 feet. I obviously don't want to do that, so I'll double click again and reset that length back to 25 feet and click apply. And now let's assume that we're satisfied with what we see and we want to take this prototype geometry and actually move it back into Staad.Pro so that we can start to work with it. That's a function that can be found on the File menu of the Structure Wizard window, and the tool is called Merge Model with Staad.Pro Model. So I'll choose that option. It gives me a confirmation dialog box that verifies that that's what I want to do. Yes, that's what I want to do. And then we're greeted with this Paste Prototype Model dialog. The purpose for the Paste Prototype Model dialog is to give us a few different ways to position the prototype within the Staad.Pro model. Back to our problem statement, we saw that the column height was 15 feet high. So one logical thing that we might choose to do in order to avoid any negative coordinates in this model is we might choose to insert this truss at an elevation of y equals 15 feet in anticipation of dropping that 15-foot tall column and having the bottom of the column end up with a y equals 0 coordinate. So I'll set my coordinates to 0, 15, 0 and say OK. We'll have plenty of opportunities to see the other options within this Paste Prototype Model dialog throughout the rest of the training, so we'll take a look at some other things that we can do with it. And now we can see that we've taken that north light truss and we've pasted it into Staad.Pro, and I can confirm that elevation by using the nodes cursor and hovering over any one of the nodes in the bottom chord, and we can see that it has a y coordinate of 15 as we expected. The last thing that we need to do is add the column. There are a variety of different ways that the column could be modeled, but what we'll do is move to the Geometry tab. Beam subtab is active by default, and we'll bring our focus over to the Nodes table. We can see that the next node that would be added to the model will take on node number 11, and we know that the truss is 25 feet long, and we set up the elevations of the truss so that the bottom of our column could be at a y coordinate of 0. The entire model has been constructed in the z equals 0 plane. So by just keying in the value of 25 for node number 11, x coordinate, we've added the node that we need to draw the bottom of the column. And what I might choose to do is come back and use the Add Beams tool, and I'll draw this column specifically from the top to the bottom to set us up to look at some results in a specific way a little bit later. So that's all the steps that are required to model the half of the truss that we wanted to create. And at this point, what we'll do is just come back to Staad.Pro, and we'll be ready to move on to the next section in the training, which will cover editing structure geometry. We'll now shift gears just a little bit and start to discuss the topic of editing structure geometry as opposed to creating structure geometry. If your model is still set to the Structure Wizard model that we created in the previous section, there's no need to save this model, because when we come back to do the mirroring step, we have another saved data set that will bring us right back to where we are currently. So what you can do at this point is just open, and what I'll do is use the icon to open a new model, and we're going to acknowledge that no, we don't want to save changes to Structure Wizard. And then what we'll do is we will browse to Modeling 3 and say Open. So this should look familiar to us. It's a copy of the model that we created with the knee braces before. And what we're going to do is talk about some of the tools that are available for editing existing model geometry. So let's take a look at a toolbar that's normally docked on the left side here. It's known as the Selection toolbar, and it consists of, or it contains, a series of individual cursor icons, some of which we've already taken a quick look at. If I hover the cursor over any one of these, we get that little pop-up tip that helps and tells us what the name of the cursor is and indicates what it selects. So for instance, we have what's called a nodes cursor that selects only nodes. We have a beams cursor that selects just beams. There's also a cursor specific to selecting plates, one that only selects surfaces, one that's particular to selecting solids. And then beneath that there's a cursor called the geometry cursor, which is a catch-all that will select any of those 5 entities. So the fact that we have these specific cursors is really convenient at times, like for instance if my intent was just to delete all of the beams in this model, I could use the beams cursor and delete all of those members and be left with all of the nodes. I can also undo, or undo all the way back to the last step to get all of that geometry back. Some other reasons why the cursors are convenient to have as individual function cursors is if you get into a situation where you're working in tight quarters and it becomes difficult to select a beam without getting a node or an adjacent plate. So you can use the appropriate cursor to get the entities and only the entities that you want to work with currently. So with that basic intro to the cursors on the selection toolbar, let's now talk about some basic cursor facts. Starting with the nodes cursor. The nodes cursor will select the nearest node when you click in close proximity to a node location. The beams cursor, the next one down on the list, will select or deselect individual members by clicking on them. And multiple members can be selected at one time by pressing and holding the control key and then clicking, and deselect certain ones by holding the control key down and clicking again. We said that the geometry cursor is one that will select any kind of geometry. So for instance, if I click on a beam, not only do I get the beam, but I get the nodes that are attached to it at the ends. If I click on a node, I get that node and the beams that are attached to it. And if I had plates or solids, I could also collect plates or select plates and solids as well just by clicking on them. The select text cursor is currently grayed out because there are no text objects in the model, but when we get to the point where we place a label on our model, we'll see that that cursor becomes available, and it becomes a way that we can adjust the position or the justification of those text labels on the screen. There's also a cursor here called the filtered selection cursor, and this works hand in hand with a configure selection filter item on the select menu. In short, what it does is it makes it possible for us to, for instance, select say just the W18 by 35 beams in a model, or only the members that are of material stainless steel, and so on. There's also a select joints cursor that's related to the RAM connection interface. We don't have any connections defined in this particular model, so that cursor is currently grayed out. In addition to using the toolbars to select, I'll point out that we can come to the select item in the menu bar, and the first third or so of that menu is dedicated to all of those same cursors. So you could, if you're more of a menu-driven person, come up here and pick your cursors from the Select menu. And then where the choice of the cursor controls what you're going to select, there's also a related setting here called Cursor Selection Modes that controls how that cursor will select. So let's just start with our basic beams cursor and show that we can click, or we can press and hold Control and click to get multiples, or click once to deselect, and now click and hold down and stretch, and notice that I'm making a rectangular fence. And when I release, the rule is any member whose midpoint falls within my fence becomes selected. If the midpoint of the member is not within my fence, then it won't be selected. So understanding that and observing that the diagonals are full length, they obviously cross at their midpoint. So I could select both of those diagonals by drawing the tiniest of fences around the crossing point, which we know to be the midpoints. And when I release, I now have selected those two crossing diagonal members. So this is the basic mode, or the default mode, which is a drag box. Let's now come back to Select in the menu bar and down to Selection Mode. And instead of the drag box option, let's select drag line. Now, when I click anywhere in the model and draw a diagonal, instead of getting a box, what I get is a line. And the rule with drag line is if the line crosses the member, it selects the member. If it doesn't cross the member, then it doesn't select the member. And again, the Control key can be used to accumulate or deselect individual members. The deselect function doesn't seem to work. So we'll correct that by saying that in the drag line mode of selection, we can use the Control key to add additional members, but we can't use it to deselect individual members. To deselect them, we'd have to come back and just click on them to change the selection set. Now there's one more selection mode, and that is what's called region. So if I come and change my selection mode to region, then what I can do is I can create a closed polygon by clicking multiple times in multiple places to draw any shape that I want, and double click to finish the selection set. It follows the same rule as the drag box in that if the midpoint of the member is included in the region, it's selected. If the midpoint is not within the region, it's not selected. So you can see that I just drew a selection region that specifically carved its way around the midpoints or the crossing points of the two major diagonals. And you can see that once I executed that selection, I selected everything except for those two diagonals, just as we expected. Finally, in addition to being able to select with the various cursors and used in combination with the cursor selection modes, I'll point out that on the select item in the menu bar, toward the lower half of this menu are a variety of other selection tools. I'll highlight some of those now. For instance, we can choose to select beams that are parallel to a particular axis, the y-axis in this case, and then I get all four beams in this model that are exactly parallel to the y-axis. Another option might be to select by range. So I could come in and say select by range, choose the plane that I want to use to create a range for. So maybe it's the XZ, meaning a horizontal plane. I remember that my frame is 8 feet high, so I could say that I want to select everything that falls between, say, a minimum of 7 and a maximum of 9, and when I execute that selection I get the top chord of this truss. Another useful selection tool is the option to select by inverse. What this does is it inverts the current selection set, and sometimes it's easier to select what you don't want and then invert it as opposed to selecting what you actually do want. So that can be a powerful tool as well. Last, I'll demonstrate that there's a select by specification option where you can, for instance, come in and select everything with a particular property name. This model has been set up so that it contains some steel members. Say I want to select the W8 by 35s, or maybe I want to select the ones that are designated as W18 by 35s, and so on. So lots of flexibility in terms of selection and working with cursors and cursor selection modes. Another common editing function is the need to delete members. So while still working in this modeling 3, I'll show that with the beams cursor active, if I click on a member and then press the delete key on my keyboard, I get a warning window that says that I'm about to delete a member, and I can confirm with OK, and now I've deleted that one member. In addition, there's some other ways to delete. For instance, I could select another member and then come to the toolbar and click the delete icon, and that does the same thing and asks for confirmation. I could also select a member and then say edit and choose the delete command from there as well. In addition to deleting in a single fashion, I can select multiple members, so I'll click on one, then press and hold and click on another member, and then use any of those delete methods. Again, it asks me for confirmation. I can say OK, and now I've deleted those two members. Along with deleting members graphically, like I've just shown, I can also, I'll just restore those two members. I can also come into the Geometry tab, Beam subtab, and discuss how we could use the tables to either delete or modify geometry. So the first thing that I'll show is that the tables are fully interactive. If I select a particular member on the screen with the beams cursor, the corresponding row of data for that beam in the beams table becomes highlighted. If I select any row in the beams table, that member becomes highlighted on the structure diagram. And likewise, if I was to choose the nodes cursor and pick a particular node, the corresponding line in the nodes table highlights, and in the other direction as well. If I select a node in the nodes table, the corresponding node on the structure diagram highlights itself. So there's interactivity between the tables and the structure diagram. The other thing I can show is that if I was to identify, for instance, this node, which is node number 5, and then come over and change the y coordinate of that member of that node from 8 to say 12 and click to a different cell, there's instant interaction between the graphic and the table. So now we can see that that node has been moved up from a y coordinate of 8 to a y coordinate of 12. And if I wanted to, I could just restore that by clicking the undo icon. The other thing that I can show is with the beams cursor active, if I was to select a member, this happens to be beam number 10, and say press the delete key and confirm with OK, the table updates itself and shows that beam number 10 is now no longer existing in this current model. And if I wanted to, say, delete beam number 4, I could select that line in the beams table, and for variety I'll come up and use the delete icon and confirm with OK. And now we can see from the list it goes 1, 2, 3, skips 4, 5, 6, 7, 8, 9. So we can use the tables and the structure diagram to modify and delete existing structure geometry. In addition to being able to modify and delete structured geometry graphically and in the tables, we can also use the Staad.Pro editor to make similar edits and modifications. So in order to demonstrate how we could use the editor, what I'll do is come up to my toolbar to open without saving changes to the current model, and I'm going to choose Modeling 4, which will restore us to a familiar condition of the portal frame with its braces and its knee braces. The Staad.Pro editor can be accessed from this icon. It can also be accessed by clicking the Edit menu and then choosing Edit Input Command File. Either way, it will have the effect of opening the Staad editor, which shows for us the input file for the current model. The input file is the file name that ends with the std extension, and while they're just simple ASCII text files, there are some benefits to working on these files within the Staad editor. One of those advantages is that the Staad editor offers syntax checking to make sure that the information that we've provided is in an understandable format to Staad.Pro. The other advantage to the Staad editor is evident in the colors that you see here on my screen. The Staad editor uses certain color conventions to identify Staad.Pro keywords and numeric data and comments and so on. The color convention is that it uses red to identify text that it recognizes as a command. It uses a black font for items that it refers to as user-defined text or labels or names, like the date that you see here. The color blue is used to indicate anything that Staad interprets as numerical values or data. And then there's also another color that I can show if I insert an asterisk before any line, which is the way that we indicate a remark statement in Staad.Pro, that it uses green to indicate anything that it interprets as a remark or a comment, meaning something that will be ignored as the input file is read in and processed. I'll just delete that asterisk to restore the joint coordinates command now so that our model actually makes sense. And then what I'll do is find a particular joint in our model. This is joint number 5 that has coordinates of 3.5, 8, 0. And just to show the effect of making an edit in the Staad.Pro editor, I'm going to change the coordinate of 8 to a value of 12, and I'll say Save, File, and Exit. And we can see the effect of doing that is the same as when we made that change here in the tables, where we took joint number 5 or node number 5 and raised it to a y coordinate of 12. So Staad.Pro has just read in our modified input file and made that change here in the table accordingly. If we wanted to restore the frame to a logical configuration, we could, here in the graphical user interface, overwrite that value of 12 with 8. We now have a level top chord again to our frame, and then if we wanted to, we could say save to write that information back into the Staad std input file. As a final comment to this section, just bear in mind that good practice dictates always working either in the tables or working in the input file using the Staad editor, for instance, but doing those one at a time. Don't ever concurrently make some changes in your Staad editor and then some other changes in the graphical user interface tables, because that will cause some confusion, and Staad will have a hard time reconciling which changes are to take precedence. Some of that work will get lost in one location or in another. So always work in just one location and then save and close at a time. Continuing along the lines of editing existing structure geometry, the next topic that I'm going to discuss is merging members. And in order to demonstrate merging members, what I'm going to do is open the next data set, which is modeling 5. No need to save changes to the current one. And then when modeling 5 comes up, what I'm going to do is use two keyboard hotkeys. One of them will be the Shift key and the letter B to turn on beam numbers, and the other will be Shift and the letter K to turn on what we call node points. Those are the small bold dots that we see appear on the screen. And by doing that, it's easy to see now that the top chord of this structure exists in 3 individual segments. We understand why that is from our previous exercises. We modeled a diagonal on each side that split this top chord up into a 25%, 25%, and 50% length. Let's just use this model and assume that we have this member that was segmented for some reason, and that for whatever reason we no longer need that segmentation to occur. We'd prefer to simplify the model back down into a condition where this top chord exists in the form of just one continuous member from column to column. So what we can do is merge these 3 members. The first step is to select these 3 members. I could use Control and then click, click, click. I could also say select beams parallel to the x-axis. However we choose to select those, the next step will be to come to the geometry item in the main menu or menu bar, and then we're going to come down and choose Merge Selected Members. The Merge Selected Beams dialog opens. It shows us the numbers of the beam segments that we have currently selected. It also offers us an option to choose which beam number we want to keep, since we'll be merging 3 different beam numbers into a single beam. So I'll choose the option to keep the beam number 2. Since these members have all the same property, there's really not a lot to decide there except to confirm that we want to keep the W18 by 35 as the section. The modulus of elasticity is indicated, the Poisson's ratio is indicated, and the density, and again all of those will be the same because I've previously defined those members as all being the same reference or the same section. But the idea here is that if we did have different properties for the members we're about to merge, we would individually be able to choose which of those properties we want Staad to retain. The last step is just to click the Merge button, and then I'll click Close, and we can see that we now have just a single member from column to column with member number 2. So the 3 individual members have now been resolved or consolidated into just one single member. Now there's a counterpart to the merge command, which is the split command. And what I'll do is continue working in this same model, and I'm going to assume that this top chord, this top member that's currently selected, wants to be segmented once again, but it wants to be segmented into 3 equal length segments. So what I'm going to do is ensure that that member is selected by clicking on it, and then I'll click Geometry in the menu bar and come down near the bottom and choose the option called Split Beam. This opens the familiar Insert Nodes into Beam such and such dialog that we've worked with before. We've already talked about the options to manually key in distances or proportions and then use the Add New Point to populate the insertion points table. We've also seen the Add Midpoint function that automatically populates the midpoint into the insertion points table. The one that we'll discuss now is the option to add some number of new points, equally spaced is the assumption, along the length of the beam. So if we want to split this member into 3 equal length segments, that implies we want to add 2 new points, so I'll leave the n value at its default of 2. I'll click the Add N Points button. Notice that it takes the length of 7 feet and it correctly divides it into thirds, shows us that the new node numbers will be numbers 5 and 8 at these locations, and then I'll click the OK button, and I can see that I now have 3 equal length members along that top chord. The next topic that I'd like to discuss in the category of editing structured geometry is working with intersecting members. And I'd like to go ahead and open the data set modeling number 7 in order to discuss intersecting members. So without saving any changes to the other files, I'll pull up number 7 and then use it to point out that in Staad.Pro it is permissible to model crossing members. The fact that members cross each other graphically does not mean that they are intersected mathematically or that they're connected structurally. We actually have to make that decision as we construct the model, and the tools that we're about to see will help us to find any of those crossing members and then ultimately to make the decision as to how to treat the nature of their connection or lack thereof. So in this model, we can see that it's not always readily apparent whether there are in fact any crossing members or not. The first tool that I'm going to show will help us to visualize members and decide whether there are any crossing or intersecting members. So I'm going to come to the geometry item in the menu bar, and then I'm going to come down to the item called intersect selected members, but I'm going to choose the second option, which is to just highlight any intersecting members. When I make that choice, I get the intersect members dialog, and it offers me an option to enter a tolerance in length units. This can be useful if a model's been created and there's some round off error or some imperfections or subtle differences in the planes of framing so that they don't actually mathematically connect. I've actually carefully constructed this model so that I know that the intersecting members that I'm about to show do fall in a common plane, and so I'm safe to set the tolerance value at 0, and then I'll just click OK. And what this does is it goes through the model and finds any occurrences of intersecting members and highlights those for us. So what we can see is that we have 4 members that intersect each other. 2 in the front plane, 2 in the rear plane. Now if our intent at this point was to create an intersection point at the locations where those members cross, then we could just go in and use the other tool that we saw, which was intersect selected members and then intersect, and that would create an intersection between all of those members. But instead, let's envision a different situation where we want to create a condition where the bracing members in the front plane are connected and transfer load at their intersection points, but we want to leave the members in the rear plane as they're currently modeled. So the way we can do that is to just ensure that the 2 members in the front plane are selected. I'll click once to deselect everything. I'll click and stretch a fence around the crossing point to automatically select the 2 that are in the front plane and just bring it back into an isometric view. And then what I'll do is come back to geometry, intersect selected members, and this time I'll choose the option to intersect. Again, we get that tolerance dialog. I'm just going to leave the tolerance set to 0 and click OK. And now we get a notification box that says 2 new beams have been created. So I'll click OK. And to really help visualize this, what I'll do now with the beams cursor is just click on individual elements in that front cross brace and show that they've definitely been broken at that common node. If I use the hotkey Shift and the letter K to turn on node points, we'll now be able to see that common node at the crossing point. Notice that nothing happened with the 2 braces that are in the rear of the structure. Another convenient editing function that's available in Staad.Pro is the ability to renumber beams and nodes. So in order to demonstrate those functions, I'll open a new data set, modeling 8, and when that model opens, I'm going to go to the Geometry tab and come over and take a look at the beams table. And I'll note that the list of beam numbers has some gaps in the sequence. It goes from number 1 to 3. and then it skips number 6 and number 8 and so on. So it might be a logical goal to eliminate the gaps in the list of the beam numbers in this model. Now it's important to understand that having gaps in the numbering of either the beams or the nodes does not impede STAAD's ability to perform an analysis or a design, but it may be convenient to eliminate those gaps just for the purpose of interpreting the output downstream. So let's assume that our goal is to eliminate those gaps. The first thing that I'll do is use Select from the menu bar, and I'll come down to the option to select by all and choose the option to select all beams. Then I'll come to the geometry item in the menu bar, and down toward the bottom I'll choose the option to renumber, and specifically it's the members that I want to renumber. We get a warning box that says that this is an irreversible operation, and so if we perform a renumbering, all of the undo and redo records will be lost. We won't be able to undo or redo this process, and in addition, the dialog warns us that if we happen to have any saved views where that existing numbering system has been displayed, then the fact that we're about to change the numbering makes those previously saved views potentially invalid, and so it reminds us that we might want to consider that and get rid of any saved views. Then it says, do you want to proceed? So with that I'll say, yes, I do want to proceed. And we get the renumber dialog. The first field is the start numbering from field. I have the option to start numbering from any number that I want, but I'll leave it set to 1. The next decision is the new numbering order. I can either do ascending or descending. I want to make sure that I'm using ascending numbering. And then what I need to do is decide what my sort criteria will be. So at this point we'll take a minute to just describe this simple selection system that Staad.Pro offers us that's common throughout many of the dialogues in Staad.Pro. It consists of a dialog or a list of available things, some tools that we can use to select certain things, and then a side or a list that indicates what has been selected. So the process is to click on one or many of the items that you want to select, and then use the buttons to move things to the selected side. The single right arrow would move just the selected items over to this side. The double-headed arrows move everything in a certain direction, and the single left arrow moves just the highlighted or selected item back out to the available criteria. So for our purposes of eliminating the gaps in the numbering, the option that I would want to choose as my sort criteria is the member number. So I'll click that option and then use the single right arrow to move that over to the selected side. It now shows me that I will be renumbering based on the existing member numbers, and I'll go in an ascending order. So I'm going to click accept, and another information box comes up that tells me now that 11 beams have been renumbered. I'll click OK, and now I'll come back to my beams table, and as I look down through the list of numbers I'll notice that everything is in sequential order with no gaps, and I can see that there have been 3 or 4 numbers that have been eliminated here because the next number that it proposes to use for a new beam would be number 15. So now that my 11 beams run in sequential numerical order, what I'll do is use the keyboard hotkey Shift and the letter B to turn on those beam numbers. And the next thing that I want to point out is that although I've eliminated the gaps, there's another issue with this numbering in that member number 1 occurs at the lower left-hand corner of the structure, and then just as a function of the way that the model was constructed and then renumbered, member number 2 occurs clear across the structure at the opposite corner. Now it may not be a big deal in a structure that's this small, but in a large structure that could consist of say an east approach span, a main span, a west approach span, and substructure elements, that could be a hindrance to interpreting data and output. And it might be desirable to renumber the beams in a more complex model so that they follow a more logical physical order, and member number 2 is at least somewhat logically located with respect to members number 1 and number 3. So let's take a look now at how we can use the renumbering command to accomplish that purpose. What I'll do is again choose select by all beams, and then from the menu bar I'll choose geometry, renumber, members. Again, I'll acknowledge that it's an irreversible operation, and yes, I want to proceed. And here again is that renumber dialog box. I still want to start renumbering from 1, and I want to work in an ascending order. But this time what I'd like to do is I'd like to base my renumbering on some different criteria. What I'll do is I'll say that I want to base my renumbering on the x-coordinate and the y-coordinate of the member. And as it turns out, it's based on the x-coordinate and y-coordinate of the midpoints of the members that are to be renumbered. So with those two selected, I'll click the single right arrow and move those criteria over to the selected sort criteria side. Now that I have two criteria selected, I can show the purpose for these two black buttons down in the lower right hand corner, which is simply to change the order of priority or precedence of the criteria that will be used for the basis of renumbering. What I want to do is ultimately make sure that I have them ordered with the x-coordinate as the primary sort criteria, and then secondary to that will be the y-coordinate. So in other words, for any member that it finds whose midpoint has the same x-coordinate as other members, it will then revert to basing the renumbering on the y-coordinates of those members in an ascending order. So let's see what this does for us. I'll click accept and acknowledge that 11 beams have been renumbered. And now what I can see is that member number 1 and member number 2 and 3 and 4 are all much more logically oriented, so that as I work my way from left to right in this structure, and generally from top to bottom, I can see that I work in sequential numerical order of the members. The next topic that I wanted to demonstrate is how copy and paste can be used on nodes, and in order to do that I'll open the dataset file called modeling 9. And what we'll do here is turn on node numbers with Shift and N on the keyboard. I'll also turn on node points with Shift and K so we can see a little more clearly where those node dots appear. Let's just assume that in this case what we want to do is create a 2.5 foot long cantilever, a horizontal cantilever, to the left side of this node number 6. So one convenient way to do that would be to copy and paste node number 6 2.5 feet to the left, and then just draw a member between those two nodes. So the first thing that I'll do is come up and I'll select the nodes cursor, and then come down and click on node number 6 so that it's now my selected node. And then I'll come up to the menu bar and say Edit and choose Copy. Then I'll immediately come back to the Edit item in the menu bar and come down to Paste, and notice that it's not just paste, but it's paste nodes, indicating that it's a node or some nodes that are on the clipboard. So I'll choose Paste Nodes, and I get this Paste with Move dialog that we've already seen before. What this does is it gives me some different ways to move the clipboard selection. In this case, what I might want to do is just come to the option to move those clipboard contents by a specific amount, and looking at my coordinate axis down here on the screen, I can see that what I want to do is move that clipboard content by 2.5 feet in the negative x direction. So I could just come and edit the x field to minus 2.5 feet. Again, that's based on the goal of creating a 2.5 foot long cantilever. And then I'll just click OK. And now I can see the new node, which is node number 10, and it occurs out here to the left of node number 6. Now it doesn't actually have anything to do with copying and pasting nodes, but what I'll do to set us up for our next step is just come back to the Add Beams tool, and then I'll add a beam from node number 6 to the new node number 10 so that we actually have that 2.5 foot long cantilever, beam number 12, with a length of 2.5 feet. I'll now continue working in the same model to demonstrate the next editing process, which is copy and paste members. Let's assume that the goal is to create a corresponding cantilever up here at the roof level, projecting off of node number 2. So the first thing that I'll do is come to the Geometry tab, and I'm going to take a look at my nodes table, and I just want to make a note that there are 10 nodes in this model. Now what I'll do is, using my beams cursor, I'll select the cantilever, and I'll say Edit from the menu bar and choose the option to copy, and then Edit. Now notice that the paste function is called paste beams because it's a beam that's on the clipboard. So I'll choose the option to paste beams. The Paste with Move dialog comes up. Now if we knew the distance that we wanted to shift this member upward, we could enter that as a Y coordinate here, but there's actually an easier way to do that based on the information that we do have, which is to choose this other option to move the clipboard contents by the distance between two known nodes. And what I'll do is say that I want to move it by the distance between node 6 and node 2. So I can enter 6 as the node number for the first node and 2 for the number of the second node, creating a vector that goes from 6 to 2 upward direction. And then I can say OK, and there's the new member connected to node number 2. Finally, what I want to do is just come back over to the nodes table and note that there are now 11 nodes as opposed to 10. The significance of there being 11 nodes is the fact that Staad.Pro automatically takes care of the condition here at node 2, where we may have had some ambiguity as to whether there was an extra node dropped on top of the existing node 2. And the answer is that Staad.Pro automatically takes care of that. It doesn't duplicate that node, and we can see that here in the member incidences for the new member that we just created. We can see that it does in fact go from the existing node 2 to the new node number 11, and that there are only 11 nodes created, so there's no duplicate node at that location. As a final comment to the copy and paste beams function, I'll just note that where we used this function on a single beam at a time, it is possible to use the copy and paste beams command on more than one member at a time by selecting a group of members and executing the same command sequence. I'll now continue to work in the same model to demonstrate an important setting in Staad.Pro that affects the way the program behaves. When we work with modeling procedures like the copy and paste that has the potential of placing new nodes on existing members, we have the ability to control whether those new nodes automatically split the member that they land on or not. And this can have important implications in terms of the connections between members. So what I'll do is just come to the View item in the menu bar and come down to Options, and then I'll choose the Tolerance item in the list on the left hand side, and I'll point out this checkbox for the option to split a member if a new node is added on a member. Let's first take a look at the way the program behaves when that checkbox is deselected. So ensure that that checkbox is deselected and then say OK. And then what we'll do is we'll select with the beams cursor the cantilever at the roof level, and we'll say Edit, Copy, and then Edit, Paste Beams, and we'll choose the option to shift that beam downward in the Y direction by 2 feet. So that will be in the Y field a value of -2 feet. And then say OK. Now we can see the new member that's been created, but the significant thing to note here is that when we select the uppermost segment of the column, we can see that it still runs from node 2 down to node 6. That column segment has not been broken at this new node number 12. The implication there is that this cantilever is not correctly connected to this cantilever for load to occur. Now there may be times when performing certain modeling steps where that is actually the intent. There may be a goal of not actually making a connection here, and so when that is the intent, this setting that we just saw is a useful tool for making sure that connections don't occur unintended, and this would be a logical way to perform that modeling step. Let's assume now, though, that we do want to create a cantilever that is connected to this member, this column. I'll just click Undo once to remove the member that we just copied. I'll come back into View in the menu bar, down to Options. I'll choose Tolerance, and this time I will select the checkbox to split member if a new node is added on the member. And then I'll click OK. And I'll repeat that same process of selecting the uppermost cantilever, Edit, and Copy, then back to Edit and Paste Beams, and I'll again shift that cantilever downward by 2 feet in the Y direction, so a -2 in the Y field. OK. And then again with my beams cursor, I'll come over and click to select column segments in the left-hand column, and now I can clearly see that node number 12 has split the column into 2 individual pieces on either side of node number 12, which means that the new cantilever that was added is connected to the column at the common node number 12. Continuing along in the topic of editing structured geometry, the next thing that we'll discuss is the mirror command. In order to demonstrate that, what I'll do is open the saved dataset file called Modeling 12, which will bring us back to some geometry that we created earlier in the section titled Using the Structure Wizard. So what we want to do in this case is we want to mirror all of this geometry about this central vertical member to create the other half of the structure. So what I'll do is select all of the beams in the model. This time with the beams cursor, what I'll do is just stretch a fence around all of them and select them that way. Then I'll come to the menu bar and I'll choose Geometry, and then I'll come down about 2/3 of the way and choose the command called Mirror, which will open the Mirror dialog box. The schematic diagram helps to understand the input that's required for this command. So starting with the model that exists, or the selected portion of the model, we have a starting structure. Then we'll have a plane that will act like a mirror, where we'll have to locate and orient the plane, and then that will produce the copy over here on the opposite side of the mirror. So let's take a look at the input that's required. The first is we need to identify the mirror plane. Looking back at our structure here, if we wanted to envision a plane that we would hold a physical mirror in order to see the mirror image of this structure in the correct way, the mirror would have to fall in the YZ plane. So I'll come back to mirror plane and just verify that the YZ plane is already correctly selected. The next thing that we would need to do is position that plane correctly so that we create the copy in the correct orientation and at the correct location. So there are a few different ways of doing that. One is that we could provide an X coordinate to locate the mirror plane. I don't happen to know that coordinate, so the next thing that we could potentially do is we could identify a node that exists on that plane by number. Well, I don't happen to have node numbers turned on right now, so that form isn't all that helpful to me at this point either. So the third option is this tool here, which is a node pick tool, and if I click that tool to activate it, the status bar tells me click on the node to use as the reference point for generation, and I get the special cursor that shows me that it's in the mode of picking nodes. So at this point what I can do is click on any node that will be used to identify the location of the mirror plane. I actually have two nodes that would serve that purpose in the structure. At the bottom chord intersection with the central vertical is one node, or I could click at the intersection of the top chord and the central vertical. Either one will do, so I've just clicked up here at the top at node number 6. Notice that it populates this input field with the node number 6, and it actually happens that the X coordinate of that node is 0, so it's correctly populated the plane at X equals such and such field with the value of 0. The generate mode gives me the option to either move the selected structure or to create a copy of it. In this case, our intent is to create a copy. The final decision is whether or not we want to mirror the member orientation when we create this copy. In our case, what we'll do is leave this option deselected, and we'll just click the OK button, and now we can see that we've created the mirror image of the selected members to complete the full structure. Now at this point, a common question is, how does Staad.Pro treat the potential for a duplicate node or a duplicate member at that common location? And the answer is that Staad.Pro takes care of that automatically for us. There are no duplicate nodes or duplicate members created on the mirror plane. But just to convince ourselves of that, what I'll do is come to the Tools item in the menu bar, and then down to the Check Duplicate item. And first what I'll do is check for duplicate nodes. This gives me the option to enter a tolerance value. I want to leave that tolerance at exactly 0 and say OK. And the confirmation box comes up to tell me that there are no duplicate nodes found in the model. And then finally I can do the same thing for members. So I'll come to Tools, Check Duplicate, Members, just to convince ourselves that there's no duplicate member created on that central vertical, and the confirmation dialog box does show us that no duplicate members have been found. The next editing tool that we'll study is called translational repeat, and in order to look at translational repeat, I've moved into the dataset file called modeling 13. Now translational repeat is similar to copy and paste in that it is a way to create multiple copies of members at one time, but it has some advantages over just copying and pasting members, and we'll see those in just a minute. Let's make the assumption that our goal in this exercise is to take the existing frame and generate 2 more copies of it spaced 15 feet apart, and in addition what we'd like to do is connect the free ends of the cantilevers and the tops of the columns, and if I press the hotkey Shift K to turn on node points, we can also see that there are still some intermediate nodes along the top chord. So we'd like to connect all of those nodes with longitudinal members. So what I'll do is, to begin with, I'll select all of these beams. We've already seen a couple different ways of doing that. What I'll do now is demonstrate a third way, which is with the beams cursor active, I'll press the keyboard hotkey Control and the letter A to select all. And then what I'll do is come to the geometry item in the menu bar, and then I'll come down about halfway and choose the option for translational repeat. This opens the 3D repeat dialog, and again the thumbnail view gives a pretty good description as to what all the different input is that's required for this command. So there's a starting structure of some sort. There is the potential to create a certain number of copies or steps, and then if the option is chosen, this tool allows us also to create the linking members between subsequent steps. So starting down here in the lower left hand corner, the first thing that I'll do is decide which global direction I want to create my geometry in. Looking at my structure in the background and my global axis here in the lower left hand corner, I can see that the Z axis would be the right direction to generate perpendicular to the plane of the frame. So I'll choose global direction set to Z. We said that we wanted to create these frames 15 feet apart, so in the default step spacing field I'll enter a value of 15. And then we said that we wanted to create 2 new frames so that we'd have a total of 3, including the original. So in the number of steps field, I'll bump that up to 2 steps. And notice that the table dynamically updates to show us that the spacing values will be 15 feet, both for step 1 and for step 2. It's also good to note at this point that the spacing values take on that default value, but that there's nothing that prevents us from coming in and overriding those values if we wanted different spacings for the different steps. In this case, I actually want all of my spacings, or both of my spacings, to be 15, so I'll just come back to a value of 15 for each one. If I move over to the generation flags category in the lower right hand corner, this gives us some options for exactly what we do and don't bring along as Staad.Pro generates these multiple copies. There's a good table in the training manual that describes these different options in detail. For our purposes in this exercise, I'll just leave it set to the option to copy or generate all. Then what I'll do is come over to these last checkboxes here and say that I do want to link the steps. As soon as I make the decision that I want to link steps, I'm given the option to create an open base if I want to. Let's assume that we do want to create an open base, which means that when we make the copies, we won't have linking members connecting the nodes at the bottoms of the columns, members that might be thought of as grade beams if they were necessary, but let's assume that we do want to create that open base so we don't create those grade beams. The last thing that I'll do as a convenience is I'll say that I want to use the option to renumber the bays. When I click this option, notice that we get a new column added to the table here. And what I can do is I can say, for instance, that I want the members in step number 1 to be numbered starting at 101. And then I want the members in step number 2 to be numbered starting at 201. And we'll see where this can be a benefit as soon as we look at the whole generated structure. At this point, I can click the OK button to execute the generation. Again, we get this courtesy box that comes up to warn us that it's an irreversible operation, and undo and redo records will be lost. Saved views based on previous numbering may also become irrelevant or invalid. Do we really want to proceed? Yes. And now here we can see the original frame still highlighted. We can see step 1 and we can see step 2 here in the foreground. We can see that we have longitudinal members that have been generated at all of those nodes. And if we were to spin the model just a little bit, we might actually be able to see that there are a couple of members in here that might not necessarily be desired. Those were created at the nodes at the crossing points of the braces. So here, if those members weren't desired, they could easily be selected and deleted. It is significant to note that even though we selected only members, not nodes, in the first or the original structure, that the nodes do in fact get copied as well. Nodes are required in order to generate these other members, so the nodes do get copied, and it's not necessary to select them in the original. The other thing that may be helpful is to take a look at the member numbering. So I'm going to turn on Shift B to look at beam numbers and pan in just a little bit. The other thing that I can do to clarify the view here is I can say select, and I want to select beams that are parallel to the z-axis. Then I can say select by inverse and choose everything except those beams. And then I can make use of a tool in the view item of the menu bar called View Selected Objects Only, which turns off the purlins and the girts and clarifies the view of the three generated frames for us a little bit. What this lets us do is note that the original frame numbering ran from 1 up to node beam number 13, and then as a result of the start numbering from 101 command, the second frame starts at 101 and runs up to 113, and the third one runs from 201 to 213. So this could be convenient when looking at output, especially for a large structure, so that you can establish some at-a-glance recognition that if you're looking at members up in the 200 series, for instance, it's meaningful that it must be members somewhere in the second step that's created, so you can create a logical association based on the member numbers. So to finish up the discussion on translational repeat, it has a couple of benefits over the simple copy and paste techniques. First of all, it allows multiple copies to be created at one time. And the other thing is that it allows these members to be automatically linked to each other if desired. And then I guess as a third option, we have the ability to control the numbering as we've seen here, so that we can establish completely different series of numberings for the different generated copies. The next tool that we'll take a look at for editing structure geometry is called the circular repeat tool, and to demonstrate that, I'll open the file called modeling 14. And what I'd like to do is turn on beam numbers with the keyboard hotkey Shift and the letter B. What I'll do here is start by selecting member number 13, the tallest column in the model, and then I'll say select by inverse beam selection so that I get everything except that tallest column. Then I'll access the circular repeat tool from the geometry menu, and about halfway down I'll choose circular repeat. Now the controls for this circular repeat are very similar to the controls that we saw for the translational repeat. So we have a graphic that indicates the function of the tool. It indicates that there's some starting structure, that which is already selected. It shows that there's the potential to make a certain number of steps. There's the potential to link those steps if desired. That we'll need to identify some geometry in order to control the or drive the generation of these multiple steps, and that'll require the location of an axis of rotation and a sweep angle and a number of steps, obviously. So what we'll do first is we'll take a look at the axis of rotation category, and we'll see that it's currently set to the y-axis. And if I wanted to rotate this structure about that tallest column, then that would be the correct axis, the global y-axis. Then what I'll do is I'll look at the through category, which provides us with a variety of ways to locate that axis. Now, if I knew the x and z coordinates of that axis, I could key those in. If I knew a node number that fell on that axis, I could key in a node number. But since I don't know either of those things, what I can do is use this tool that's a node pick cursor. I get the special node pick icon on my cursor, and then I can come down and just click on a node that falls on that axis of rotation. So I'll pick the node at the bottom of the column. The last thing that I'll point out is that there's an option here to use this as a reference point for beta angle generation. Beta angles simply describe the orientation of individual members with respect to a rotation about their own longitudinal axis. So if for the purpose of conversation, if this member happened to be, say, a channel section with its web oriented in the plane of this frame, and if I chose the option to use this as a reference point for beta angle generation, then all of the subsequent steps that I generate around this axis of rotation would be rotated so that the webs would all be pointing through this axis of rotation. I'll leave this checkbox deselected, which means that the member orientation would not be rotated as I just described, but it won't make any difference for the purpose of what we're looking at here in this step. The next thing that I'll do is come to the total angle field, and I'll just observe that it's set to 360 degrees. That's exactly what I want it to be because I want to create a closed structure, something that wraps all the way back around on itself. My goal is to create an 8-sided structure, so I'll just use the arrows to increase the number of steps to 8. And then notice that there's a geometry only checkbox, which is similar to the controls that we saw in translational repeat, but without quite so much finite control. But it just provides a way to indicate to Staad.Pro that we might want to just generate the geometry and leave all of the properties and specifications behind. We won't worry about that setting for our purposes here. What we will do, though, is we'll come to the link steps checkbox, and we'll make sure that we check that or select that checkbox. Once we do that, we're given the option to create an open base if we want to. I'll go ahead and say that yes, I want to create an open base as well. With that, I can just click the OK button, and there I can see my 8-sided structure that's been generated as a result of those parameters. Now, let's just clarify the screen a little bit with Shift and the letter B to turn those beam numbers off. One of the common questions that comes up again here is, does the original structure get duplicated back on itself when I indicate 360 degrees and 8 steps? And the answer is no, it does not. Staad.Pro is intelligent enough not to duplicate that initial frame. One might be inclined to say that the goal is really to create 1, 2, 3, 4, 5, 6, 7 steps and only go 315 degrees, and you could certainly do that. The disadvantage to doing that is that what we would end up with in that case is something that looks just like that, where it wouldn't close back on the original structure. So the point is not to be afraid to go ahead and indicate a 360 degree generation, and just be confident that Staad.Pro won't duplicate those members on the original or the starting structure. The other thing to note here is that when we began the exercise, we selected that tallest central column, and then we made use of the invert select command to get everything except that tallest central column. And in reality, with the 3D circular repeat command, Staad.Pro also will not repeat or duplicate any members that are on the axis of rotation. So even though we went through that step, we didn't actually have to do that in order to successfully generate the geometry that we see here. The next subject that we'll discuss, continuing along the lines of editing structure geometry, is what we refer to as orphan nodes and how to identify and remove orphan nodes. And in order to take a look at those, we'll open dataset file called modeling 15. Now, orphan nodes are simply nodes with no structural attachment to any part of the rest of the model, and they can be created in a number of ways. They can be the result of some inadvertent clicks on a grid during a modeling process or some incomplete editing in the Staad.Pro editor, for example. Sometimes orphan nodes are created intentionally. They may serve a meaningful purpose to mark a control point or a point where another piece of a model will be inserted at a future date. They may serve as a working point or a center point for a generation of circular elements. And so there's no problem with working with orphan nodes during the modeling process. The problems come in when an analysis needs to be performed, because while orphan nodes can be present during modeling, they should not be left in place during an analysis. They can cause errors. And so we have some tools that are available to identify, and then if we choose to actually remove any orphan nodes that may exist in the model. So what we'll do is, with the beams cursor, we'll come in here and we'll select these two cantilevered beams. I'll press and hold Control and click to get the second beam, and then I'm going to press the delete key on my keyboard and confirm with OK. And then we get a second warning box that says deleting beams has left some nodes with no structural attachment. Do you want to delete these nodes? So this is a convenient way to warn us that we're about to create some orphan nodes. And in this case, I want to leave those orphan nodes so that I have something to talk about. So I'll say, no, I don't want to delete those nodes. Now, they're not very obvious at this point, so what I can do to make them more obvious is use the keyboard hotkey Shift and the letter K to turn on node points, and now we can see that the nodes that used to define the free ends of the cantilevers are still out there in space. Now let's turn those node points back off, Shift K again. And let's assume that we have a complex model where it's not quite so easy to spot those two nodes hovering out in space with no attachment. And let's make use of a tool that's available to help find those for us. So I'll come to the Tools item in the menu bar, and then I'll come to Orphan Nodes. And then what I'll do is choose the first option, which is to highlight orphan nodes. And what that does for us is just goes out and makes any orphan nodes that may exist in the model highlighted. So they're now bright red and easy to see. At this point, we could make a decision as to whether we wanted to keep either or delete both of these orphan nodes. Let's just assume now that we want to eliminate both of these orphan nodes that are selected. So what I'll do is come back to Tools in the menu bar, Orphan Nodes, and this time I'll choose the second option, which is Remove. And now those orphan nodes have been removed for us automatically. If I press Shift and the letter K, I can see that there are no nodes out here, and I can confirm that by going to Tools, Orphan Nodes, Highlight, and now I get a information box that comes up and it says no orphan node is found. So we've successfully deleted orphan nodes from this model. Next, I'd like to show how we can combine two or more Staad.Pro models by using a copy and paste technique. We'll take a quick look at a section of the training manual to see the basis for this example. We're going to work with two different models here. The thing that's of significance is to understand that this only works if the models are coordinated so that they actually fit together. Specifically, the width of the portal frame is 15 feet and the width of the braced frame is also 15 feet. So because they match in width, I'm going to be able to demonstrate by copy and paste that I can copy one piece of framing from one model and then paste it into another model, coordinate the location, and end up with the two pieces of framing in the same model. So let's come back to Staad, And what we'll do first is open the file called modeling 16. And this is our braced frame model. What I'll do is use the beams cursor to select all of the framing, and then I'll say edit and copy. Then what I'll do is I'll say open structure again, and this time I'll open the file called modeling 17, which will be the portal frame. And then what I can do is just come to edit. Notice that the paste function knows that there are beams on the clipboard, so I'll click the paste beams tool. We've seen this paste with move dialog box, and we've used a couple of different versions of it so far to locate the current clipboard contents. What we'll do this time is use this reference point button. What this does is it shows us a view of the contents of the clipboard, and it allows us to pick any node on those contents to act as the current reference point. The logical places to pick as a handle point or a reference point for the work that we're about to do would be either of the two bottom nodes here. So I'll just use the lower left hand corner. By the way, I just rotated the model with the arrow keys on my keyboard a little bit to bring that lower left hand node into view. Once I select the node that I want to use as my reference point, I can click OK. And if I read the status bar, it says click on the node to move the reference point to. And I see that I've got that special cursor that indicates that I'm moving from a node to a node. So what I'll do is say the lower left corner of the braced frame wants to sit on the top left corner of the portal frame. I'll just click at that location, and the paste with move dialog comes back and shows us that the y coordinate has been populated to a value of 10 feet. Now I recognize that as being correct, but if for some reason you clicked in close proximity to multiple nodes and happen to snap to the wrong one, you could always come in here and just edit those x, y, and z values manually. But since I know that I want it to go to that location, I'll just click OK. And now I can see that I've got my braced frame placed directly on top of my portal frame. I can come back up and just convince myself that there are no duplicate nodes by coming to Tools, check Duplicate, Nodes, enter a tolerance of 0, say OK, and it confirms for me that at the location where it placed the bottom nodes of the braced frame on top of the top nodes of the portal frame, it did resolve those duplicate nodes correctly. Now that we've seen how this method of combining multiple models can be done, I'll describe an example of where it may be a useful function. If we envision a real-world application of some sort of a large structure that could have multiple spans to it in the sense of a bridge, or it could be a large building or some other sort of structure, we can easily envision a situation where there's a common grid that's established for the project, and then it's shared to multiple engineers working in different Staad.Pro models. And then we can envision that these multiple engineers advance their portions of the project simultaneously, and then at whatever predetermined time that the individual models are complete and ready to be combined, they could be brought together in the way that we just did with the braced frame and the portal frame, all compiled into one single model at which point the final modeling steps could be completed, and then the entire combined structure could be analyzed and designed. We've now completed our discussion on the topics of creating structure geometry and editing structure geometry. So the next thing we'll do is move into a discussion on the tools that are available in Staad.Pro for viewing structure geometry. So the first thing that we'll do is we'll open dataset model named Modeling 18. And we'll start by talking about the structural tooltip options. So with the beams cursor active, what I'm going to do is just hover my cursor over the horizontal member here, and note that we get a little yellow box of data that pops up. In this case, it says that it's beam number 2 and that its length is 15 feet. Now this is what we call the structural tooltip, and it's actually configurable information. So I could come to the view item in the menu bar and then down to structural tooltip options, and I get this tooltip options dialog. The first thing that I'll show is the fact that we have the ability to turn structural tooltip off completely if we choose not to use it with this checkbox. If we do want to use it, we have control over what's called the tip delay, the number of milliseconds that you need to hover over an entity before that pop-up shows up on the screen. And then I can show that in the left-hand list you have information or options to choose settings for nodes, beams, plates, solids, and surfaces. So those 5 entities that we discussed before. I'm just going to come to the beam entity, for example, and then show that we have options to turn on and turn off the display of things like the member number and the length, as well as things like the member incidence, a long list of other things like the properties, and things that even get into results like end forces and the ratio having to do with design and so on. So that's all structural tooltip options. I'm going to just close this dialog and go to the next thing that we have available to us for viewing structure geometry, and that's what we call the query function. What I'll do again is use the beams cursor, and I'm going to come up, and this time I'll double click on this horizontal member. When I do that, we get this query dialog box that opens up specific to this particular beam. It happens to be beam number 2, and it shows us information about the section, gives us some geometric information, gives us the end nodes and the coordinates of those nodes, and then more information that's available down here to describe this particular beam in the model. You can see that some of these things even have buttons that allow us to make changes to some of these other pieces of information, and all of this occurs on the Geometry tab. If I was to move to the Property tab, we get some even more specific information about this specific beam, the W8x31, and more geometric properties, physical properties, material properties, an ability to change the material assignment, and so on. And then if I click the Loading tab, we have information on the loads that are currently applied to this member, the different load cases that exist, and an ability to add load items, remove, and edit load items, some of which is a little ahead of where we've already gone, but it's important to know that you have this member query that gives you a lot of information about any particular beam that you double click. I'll close the member query and choose the nodes cursor and show that if I double click on any node, there's also a corresponding node query dialog box. The node query is set up a little bit differently. It indicates the node number and the coordinates of that node, and then it provides links to tables that pertain to that node, things like the nodes table for the entire structure, the supports table that describes the boundary conditions of supported nodes in the model, and then tables that describe loads and some output information, reactions, and displacements. I'll close the node query dialog, and what we'll do next is discuss displaying structure labels. What I'll do is I'll right click in the screen here, and from the pop-up menu I'll choose the Labels command. That opens the Diagrams dialog, and it'll be open automatically to the Labels tab. When you look at the Labels tab and glance down this left-hand side, you'll see categories that correspond to those 5 types of structural entities that we have available to us: nodes, beams, plates, solids, and surfaces. So we can do things like turn node numbers or beam numbers on and off from this page. We can also turn on the display of other things like the beam end colors to establish which end of a beam is the starting end and which end is the ending end of a beam. Or we could turn on something like the orientation of a plate and so on. There are also other categories here, one having to do with physical members. We can turn on the display of different views of the properties that have been assigned to beams, some loading information, and then some general information that we can control. I've also made reference to these keyboard hotkeys throughout the training so far, and this piece of information down here says, for quick access to the labels using keyboard hotkeys, press Shift plus the letters shown in brackets. So all of these letters associated with each of these different labels is a keyboard hotkey. We've so far already used node numbers, Shift N, beam numbers, Shift B. We've turned node points on and off with Shift K, and so on. So those make for a quick way to display or toggle on and off the display of labels for different entities in the model. I can actually show that by closing the diagrams dialog and then pressing Shift N to turn on the display of node numbers, and then it acts like a toggle, so if I press it again I turn the display back off. Now what I'll do is I'll use Shift B to turn on the display of beam numbers, and I'll use that to move into the next topic, which is modifying label appearance. So we can actually control the way that these labels appear on our screen. We can find that tool in the View item in the menu bar and then come down to Options, and then we could come to Beam Labels. Notice there's also a Node Labels, Plate, Solids, and Load Labels options as well. Here within the Beam Labels we can choose from a variety of built-in styles of labels. Right now we've chosen to just use the single digit format. We can choose from a variety of different styles that can be used to indicate the reference, which is the section that's been assigned to these members. There's control over the horizontal and vertical alignment of these labels. So for instance, I could make a visual change here by setting these things both back to 0, and then I can click the Apply button at any time, and you can see that a change has been made to the alignment of those labels. There's also a font button that opens up options to change the font style, the size, the color, and then some effects that can be used. So if I wanted to, instead of showing my beam labels in Arial, bold, italic, I could choose, say, Arial, narrow, regular, OK, apply, and then differentiate the labels for nodes from the labels from beams by the way that I actually style the labels and color code the labels. I can also choose this opaquing function, which is helpful in situations where we have labels that overwrite the beams themselves. It'll create a little whiteout effect. If I move my labels up a little bit and click Apply, we should be able to see that. Now we can see that a small section of that beam has been whited out to clarify the label. Same thing here with the label number 2. And the angle text option helps to establish the relationship between the individual labels and the beams that they apply to. For instance, when I don't angle the text, the number 4 and 5 overwrite each other, and with the opaquing function turned on, the 5 takes precedence over the 4 and it completely obliterates it. If I turn the opaquing function off, we get 4 and 5 right on top of each other, so using the angle text makes for an easy way to recognize which is member 4 and which is member 5. I'll now close the options toolbar here, or dialog, and the next thing that I want to do is I want to discuss displaying member lengths and distances between two nodes. In order to do that, what I'll do is open the dataset file named modeling 19, and then what I'll do is move to the Tools item on the menu bar, and I'm going to come down to the Dimension Beams tool. When I choose this tool, I have the option to display dimensions for every beam in the view, or only to selected beams, or to beams that I could type a list for. So what I can do is just click the display button, and all the beams in the view become dimensioned. Now when we see the effect of this tool, we can notice a couple things right away. First, it's going to label every single individual member with a length. So for instance, we're back in a model here where we have 3 individual segments to that top chord, so each one of those segments gets a label. And if that's not the intent, if what we would prefer to do is see the overall length, say from column to column or from free end of cantilever to the other column, then displaying the dimensions may not be the most convenient tool to use in a model like this. The other limitation to the dimension beams tool is that it only dimensions the beams themselves. It doesn't allow us the ability to pull a dimension, say from the bottom of one column to the bottom of the other where there is no member, or to pull a dimension from one point on this cantilever to the crossing point of the diagonals. So we actually have another tool that's more convenient for those kinds of things. Let's just clean up our screen first so that we can get ready to show that other tool. What we'll do is, with the display remove dimension dialog box still open, I'll just click the remove button. It will be all of the dimensions from the view. I'll click the remove button and then click close, and now we've taken all those dimensions away. Now the other tool that I mentioned can also be found on the tools item in the menu bar, and it's right below dimension beams. It's called display node to node distance. If I click that tool, I get a special cursor that indicates that it's in the mode of displaying these node to node distances. And now what I could do, for example, is I could click at the free end of the cantilever and then stretch all the way over to the right hand column and see quickly that the overall length of that member is 9.5 feet. Or I could click say from the free end of the cantilever down to the bottom of the column if I needed to triangulate a dimension and figure out what the dimension is from points in space to other points in space. Now the way that the display node to node dimension tool works as far as removing dimensions is we have 2 options. One, we can remove node to node dimensions on a single basis by just redimensioning between those same 2 nodes, and it'll remove that dimension. And if I click and click, it'll remove that dimension. The other option that we have is under the tools item in the menu bar. There's a related icon called remove node dimension, and this will just remove all node to node dimensions in the current view. Continuing along the lines of viewing structured geometry, the next thing that we'll talk about is controlling the view, and in order to demonstrate some of those controls, I'll open the file called modeling 20. Now we have a few different ways that we can control the view in Staad.Pro. What we'll do is we'll start by looking at what's called the rotate toolbar. It consists of a variety of icons that allow us to quickly go to preset views, so we can view from the positive Z direction or the negative Z, from the X and from the Y. Of course, this structure is symmetric about these axes, so we don't see a lot of change. We can go to a view from the positive Y. We can do negative Y, isometric view. In addition to those preset views, we have the ability to rotate in increments about each one of the 3 axes, so we can click these tools one at a time and rotate or spin the structure. And then beside the rotate toolbar, we have this other one, which is called the view toolbar. The view toolbar, let's just come back to an isometric view here, has some tools that are worth working through and describing one at a time here. So the first tool is display whole structure. The purpose for this tool is that it turns on all members in the structure in case anything has been temporarily turned off from the view. It also returns the structure to an isometric orientation, so we can demonstrate that like this, and it resizes the structure to the maximum size that will fit within this main window. So if I was to shift, zoom, and let's get a different orientation, I can fix all of that in one click with the display hole structure tool. The tool that's right next to it is dynamic zoom. The way that dynamic zoom works is I can click this tool and then stretch a fence around a particular area in this model, and what that does is it establishes a zoom window and automatically opens this new window, floating window here, that zooms in on just that little area. If I scale the zoom window, I also see a corresponding change in that little representative box. If I use these scroll arrows to move or pan up and down, I can see that window moving. I can also take the little view in the main window and drag it over to a particular joint and then click back onto this window and see a zoomed in view of that area. So that's how this dynamic zoom can be used. I'm going to close the dynamic zoom window now and move on to the next one, which is zoom extents. Now, zoom extents is very similar to display hole structure, with the exception that zoom extents does not turn on any elements that may have been currently turned off. We'll see how to turn off selective elements in a step or two here, but what zoom extents does do is it returns the structure to the isometric view and it resizes it to the maximum size that'll fit within the main window, but it will leave off any elements that have been currently turned off. In addition, we have the obvious ones like zoom in, which zooms into the structure a set amount per each click, and a zoom out button that zooms backwards. There's a zoom by a certain factor. There's a zoom previous that restores the zoom to just the previous zoom level. So if I try to demonstrate that, there's also this zoom window that I'll use here to zoom in just on the ridge of the structure here, and then if I use the zoom previous button, I'll come back to the previous zoom level that I was at. This icon is called previous selection, and it doesn't actually have to do with the view itself, but it has to do with what has been selected. So if, for instance, I select a couple of rafters here, and then I click on the screen to deselect those, I can come back to that previous selection quickly by clicking this tool. I believe that the reason that it's included on this toolbar having to do with zooms is that it's a common problem that you might have something selected and then decide that you want to window in on it and accidentally click and lose your selection set. And so when you're in the mode of working with your zooms, you might want to just come back and quickly recover that selection set. So that's called the previous selection icon. There's also a tool for panning where you can drag and move the structure around on the screen. There's this magnifying glass tool that lets you quickly blow up an area when you click the mouse button, and then if you release the mouse button, it goes away to the magnifying glass cursor until you click and hold and move around again. To get rid of that tool, you just toggle it back off. And then there's a 3D rendered view that can be used to display the structure in a 3D rendered mode. It's only showing lines at this point because this particular model doesn't have sections assigned to the beams and braces, so it doesn't have the information that it would need to show a 3D rendered view of the structure showing section shapes, but it does give us the ability to work around and to pan by dragging and rotating. We can also use the mouse wheel to zoom in and zoom out, which is a good point that back here on our discussion of all these different zoom tools, while they're convenient to have and good to know, oftentimes with a wheel mouse, the mouse is all you need to do all you want with zooming and panning. If I click and hold the wheel of the mouse, I can pan without ever having to come up and use the pan icon. If I roll the wheel of the mouse forward, I zoom in. If I roll the wheel of the mouse backward, I zoom back out. So lots of flexibility there. Now we mentioned the ability to turn on and turn off selected objects. So let's see how we could potentially do that. Let's assume that our goal here is to turn off the display of the hip rafters in that central column in this model. What I'll do is I'll come to one of our preset views, the view from the Z direction, just to get an orthographic projection of the structure. And then I'm going to come to the select item in the menu bar and down to selection mode, and I'm going to choose the drag line mode of selection. And then I'll drag a horizontal line that cuts across the rafters and the central column. And once I do that, I'll come back up to the isometric view just to get us back into a familiar view and quickly see that I've selected only the hip rafters in the central column. Now what I'll do is say select by inverse beam selection, so that I've selected everything except for the hip rafters in the central column. And then I'll come into view and use view selected objects only, which has the effect of turning off the central column and the hip rafters. So this is a way that we can view only certain entities, and if I move around and pan and rotate and spin, I only see the things that I have selected currently. And then, as we saw before, if we wanted to bring everything back, we have at least a couple choices. One is we could use the display whole structure, which would reorient the structure into that isometric view, rescale it, turn on everything that's hidden. Or I could just leave it in the current orientation and then say view and toggle the view selected objects only checkbox off. And now here again I can see the hip rafters in the central column. The last thing that we'll talk about having to do with viewing structure geometry is the ability to isolate a portion of a structure into its own view. So what I'll do is continue to work in modeling 20. I'm going to come to a view from the positive Z direction so that I can look at an edge on view, and I'm going to come back to selection mode and reset it to a drag box mode. Now let's assume that what we want to do is isolate the framing members that occur at the eave elevation of this structure. So what I'm going to do is just stretch a small rectangle that's large enough to encompass all of the framing members at the eave elevation, but not so large that it incorporates the midpoint of the rafters, the column, or any of the framing members below the eave. So it's just a small rectangle. And then to show that more clearly, what I'll do is come into an isometric view, and we can see that that's all that we have selected. Then what I'm going to do is I'm going to say view, new view, and I'm going to click the option to create a new view, a new window for the view, and then say OK. And here is that new view. It's an entirely separate window that contains only the selected entities that I have highlighted over here in the main window. Now let's assume that this view is a useful one to me and that I plan to do a lot of work, maybe to do some more modeling on these members and these members only. So it's worth saving this and being able to come back to it quickly. What I can do is I can come to View, and I can come down to View Management and then choose the option to save this view. Let's just give it a meaningful name. I'll call it Eve and then say OK. Now the title of this view shows up here as Eve, and I'll close the view just to be able to show you that I can come back to View, Open View, and see that my list of saved views appears here. I can choose Eve, decide whether I want to display it in the active window or again create a new window for the view, and then say OK, and there is my saved view. The last thing that I want to demonstrate is that if I was to use the Add Beams tool and come in and draw some members in this view, that notice you see those beams appearing in real time in the whole structure view, because I am actually creating entities or elements in this model. I'm just doing that in this saved view. So it's a fully live, fully functional view of the model that can be used, and you can see those effects right here. One final comment on views is that the saved views that you create for a model end up being recorded in an auxiliary file that carries the same model name as the structure itself, but it has an extension of REI S-Pro auxiliary data. So you'll be able to find that file in the list of other files that get created when you save your model. And if you were to send your model to someone else and you were to reference those views, you'd need to make sure that you also sent that auxiliary file data so that those saved file names or saved view names will be meaningful. In conclusion, the model generation module began with a thorough look at the start page, and then moved into the process of setting up a project in Staad.Pro. We moved on to discuss the use of grids, and we covered the 5 different types of structural entities that are available to work with in Staad.Pro. Then we covered the tools and techniques that are available for creating structure geometry, editing structure geometry, and finally viewing structure geometry. This now concludes the presentation on model generation.